Now we'll go to the next problem. A hexagonal lamina of sides 25 mm is placed on one of its sides on VP. The side opposite the side on which it rests is 30 mm in front of VP, and the side on which it rests makes 45 degrees to HP. Draw its projections. Also determine the inclination with reference planes. So here, a hexagonal lamina of sides 25 mm rests on one of its sides on VP. So since it is on VP, so obviously we have to start the problem from vertical plane. So where is the vertical plane? It is in the front view. So that means we have to start the problem from the front view. So he says one of its sides on VP. So the side which is resting on VP has to be perpendicular to VP, perpendicular to HP. So because why it has to be perpendicular to HP? Because so in HP we will going to get a point. So that is our condition. It is very similar to a side which is resting on HP has to be perpendicular to VP. So when the perpendicular to VP in so when the side is perpendicular to VP, so in VP you will go to get a point. So that is where we can able to rest this side on rest on that. So similarly here also, since it is resting on VP, so obviously that edge has to be perpendicular to HP. So in HP I will going to get a point here. And here since it is a hexagon, so that means it is a even side. So side opposite to that will always be a side. Corner opposite to this is a corner. So here is one of its sides on VP. So here the first condition is a hexagonal lamina of 25 mm side rests on one of its sides on VP. So we are keeping all the sides on VP now. So since all the sides are in VP, so that means it is parallel to VP. So once the surface is parallel to VP, so I am getting once the surface is parallel to VP, obviously that surface is perpendicular to HP. So in HP you will going to get a line here. So this is how we are going to have the 3D analyzation. But when it comes to 2D, again you can see that all the sides are parallel to VP. So you can see that is the true shape here of 25 mm side. Since the surface is perpendicular to HP, so in HP you will going to get a line. So here the side opposite to the side is also on VP. So here also the side opposite to the side, which is that A dash F dash is the F one side, and opposite that side is C dash D dash. So here this is also a point and this is also a point. So now in the next position he says the side opposite to the side on which it rests is 30 mm in front of VP. So here in the first case both the sides are on VP. Now he says one of the side on which it rests is 30 mm. The side opposite to the side on which it rests is 30 mm in front of VP. The side opposite to the side on which it rests. So on which it rests, what is that rest? AD is the one which is resting on VP. AF is the one which is resting on VP. The side opposite to the side is CD. CD now it is also on VP. Now he says 30 mm in front of VP. So I am drawing a line from the XY line. I draw a line at a distance of 30 mm and measure the length from here to here. From A, you cut an arc on that horizontal line to get the inclination. Then join A to C directly. So you will going to get AF and CD and measure the length from A to B by using compass. From this A, you cut an arc on this to get the point BE. So you measure an inclination of this because he says determine the inclination with the reference planes. So that the inclination is 43.85. This is when I have done in a computer, but when you do it manually it will be 44 degrees. So here this is in front of VP by 30 mm. So the side AF is on VP and the side CD is in front of VP by 30 mm. So that is the one which we are going to see in here. Since the surface, now the surface obviously becomes inclined, but still that surface inclined to VP, so still that surface is perpendicular to HP. So that is the reason why you are getting a line here. So in 2D also you can see that this will going to be the line. then the side on which it rests makes 45 degrees to HP. So here, this is the inclination what he has given is the true inclination. Now we want to check, though the side on which it rests is 45, the side on which it rests has to be in true length, because then only on the true length line we will going to have the true inclination. So we have to check whether that line is in true length or not. So when you consider that, you can see AF, you can see AF is parallel to VP. So since it is parallel to VP, so I am getting the true length in VP. So here AF is the one which is parallel to VP, so I am getting the true length. A dash F dash is in true length. So why I have to represent only A dash F dash? That is because the side on which it rests. So which is the side on which it rests, which is AF. You cannot rotate, you cannot make this as the one as 45 degree because this is in front of VP. But you have to give this AF is inclined at 45 degrees to HP. Even if you make 45 degrees to HP here, and this C dash D dash is also 45 degrees to HP only, but CD is in front of VP here. So, but that is the one which is not to be shown with the dimension. This one which has to be shown is AF only, because that is the side which is resting on VP. So once this, how to construct this figure is like this. First, you draw a 45 degree line, measure the length from A dash to F dash, consider any point from here, you cut it. So you get this line first. Then through A dash and F dash, you have a perpendicular, two horizontal lines here. So from A dash, this line is perpendicular to A dash F dash, and this line is also perpendicular to A dash F dash. So through A dash and F dash, by using a protractor, measure an angle of 90 degrees and draw a perpendicular line to this inclined line A dash F dash. Then measure the length from A dash to C dash, and since A dash C dash and F dash D dash are equal, measure the length from A dash to C dash by using compass. From A dash you cut an arc on this, and also from F dash you cut an arc on this to get the point C dash D dash. Then again from A dash you measure the length till here. From A dash you cut an arc on this. Similarly from F dash you cut an arc on this. So join these 2 points and extend on either side. Then measure the length from this point to B dash. From this point you cut an arc on this to get the point B dash. And similarly from here you measure the length from this point to E dash by using compass. From the same point you cut an arc on this to get the point E dash and B dash. Then complete the hexagon and write the corresponding top view. How? You draw a vertical projector from here and you draw a horizontal line from here to get the point A. And similarly F, because AF is on XY line, so here also AF is on XY line, and draw a vertical projectors from B dash and E dash, and draw a horizontal projectors from B and E to get the point BE here in the top view. Similarly draw a vertical projector from C dash and D dash, and draw a horizontal projector from CD to get these 2 points to complete the sketch. If you see this sketch and also this sketch, which will almost sees the resemblance, and also this A dash is on VP, so AF is still on VP. So this is how we will be able to solve the problem. Next, this is the final solution of 2D analysis, how we are able to write it in the examination, and we have to give the inclination. And don't give the inclination up to the second decimal point, which has to be shown only in your CAD drawing. But when you are considering it on manual, always you mention it is only 44 degrees. Now how to construct the hexagon? If you can draw a vertical line from here. You measure the length of A dash F dash of 25 mm. Through this point you draw a measure. From this point you measure an angle of 120 degree here, and then you draw a line. Similarly from F dash you draw a 120 degree line with respect to this, and then measure the length from which is 25 mm. From A dash you cut an arc on this. Similarly from F dash you cut an arc on this to get the point B dash and D dash. Again you, by making in the protractor, by keeping it of the protractor here, measure the inclination of 120 degrees with respect to F dash E dash, and then you mark this line. From here you cut an arc of 25 mm, you will get the line. From here you draw an arc of 25 mm here, and so from here B dash draw an arc at C dash to cut the arc. So this is the one method which will now normally we will going to follow. But since we have this edge method, so we can see first you draw a vertical line. Then what is the size of this? The size of this is 25 mm. So here you take, here it has been shown as the diameter 50. So it has to be shown as it is for 30 mm which we have considered. It is not 30 mm, it is 25 mm. So you take the 2 times the diameter. So what will going to be the 2 times the diameter? The 2 times the diameter will going to be 50 mm. So you draw a vertical line of 50 mm, and then from here you take a radius of 25, cut an arc on this side and also on this side. Similarly, you from here also from opposite end, again you take an arc of 25 mm and you 25 mm to cut this on this side, and then join all the 6 sides. You are going to get a size of 25 mm. But here what I have shown is for 30 mm size. So what we have done is you draw a vertical line, and then from this point you take an arc of 30 mm and cut an arc on this side and this side. Similarly, from this point you take a radius of 30 and cut an arc on these two, and then complete the sketch by using the hexagon. If it's on edge position for 30 mm side, if it is for 25, repeat the same procedure for 25 mm side. That means it is the 2 times the diameter. If it is 2 times the size, if the size is 25, you take 50. If the size is 30, you take 60. So this is how we can construct the hexagon by using corner method, by using the compass. So there is no need for using the protractor.